In this chapter, we're going to cover carbohydrates and nucleic acids. We're going to start with a basic introduction to carbohydrates. A carbohydrate is another name for what is often called a sugar. From an organic chemistry point of view, a carbohydrate is a structure that has an aldehyde or ketone on one carbon, and then hydroxyl groups attached to all the rest of the carbons. So a polyhydroxy, multiple hydroxy aldehyde or ketone. The interesting thing about carbohydrates is that when they were first discovered and characterized to get the formula, all of the carbohydrate molecules had the empirical formula carbon H2O. As a result, the chemists that were analyzing these named them carbohydrates because this formula, this empirical formula, has the same format as the formula of a hydrate of a salt. So you may remember, for example, that we worked with hydrates such as MgSO4 magnesium sulfate .7H2O. So this looks like a hydrate of carbon, thus the name carbon hydrate. When you have an empirical formula, often the actual formula of the molecule is a multiple of that. So this can be represented as C to the N, where N is an integer, H to the 2N, ON. Later, it was discovered that there are substances that, while themselves do not have this exact formula, when treated with aqueous acid to be hydrolyzed, they can be hydrolyzed into pieces that do have this formula. And so these are also considered carbohydrates. If we look at the structure of a carbohydrate using chemical structures, we can see that a sugar is a chain of carbons. It has one carbonyl, one C double bond O, either on the end, making it an aldehyde, or in the middle of the chain, making it a ketone, and then a hydroxyl group attached at every other carbon. This means then that the sugars themselves are divided into two categories, one being a sugar that has an aldehyde carbonyl, in other words, an aldehyde sugar, and sugars that have a ketone carbonyl, we call a ketone sugar. When sugars were discovered, they were often given common names, but once they were recognized as being carbohydrates or as being sugars, the common names were usually ended in OSE. One important part of carbohydrate chemistry is just understanding the definitions and naming conventions of the different sugar or carbohydrate molecules. A number of terms have been developed to categorize the sugars. So, for example, as mentioned, a sugar could be either an aldehyde or a ketone. Organic chemists have developed the names aldose to represent a sugar that contains an aldehyde, and ketose to represent a sugar that contains a ketone. Notice that these category names end in OSE, thus indicating that they apply to a sugar molecule. Similarly, we can characterize the different carbohydrates according to the number of carbons in the chain. Some of the more important ones are triose, which is a 3-carbon sugar, tetrose, a 4-carbon sugar, pentose, a 5-carbon sugar, and hexose, a 6-carbon sugar. Most of the biologically important sugars are one of these 4 types of sugars. Saccharide is another name that can be used for a sugar. This is often used when discussing molecules that can be built up from single sugar molecules into molecules connected that have multiple sugars connected together. So for example, a compound that contains a single sugar would be called a monosaccharide. Mono basically meaning one. If a molecule contained two sugars that were connected by a covalent bond, we would call that a disaccharide. And similarly, if a compound contained many sugars connected by covalent bonds, we would call that a polysaccharide. We will see throughout this section, and when we move into biochemistry, that these terms commonly appear in describing the reactions or the molecules that participate in the biological processes.